name is Nadia Post, and this is my Lab 1 charge tapes for Physics 2212. The objective of the lab was to observe the interactions between two pieces of U-tape and use those to find the excess charge on a piece of tape and also determine the charge of the U-tape, either positive or negative. Our results were that the U-tapes did repel each other because they had the same charge. The U-tapes were positively charged. The charge on each tape was 1.868 times 10 to the negative 8 coulombs, and that the magnitude of excess charge was 1.17 times 10 to the 11 electrons. Continuing with that, we assumed that air resistance was negligible, that the long tape is treated as a point charge with the charges concentrated at the center of the tape, and that the U-tapes have similar charges or equal charges that are distributed equally along the length of the tape. The physics principles that we used were the electric field and force equations, Coulomb's law, Newton's second law, and the relationship that the force of gravity was equal to the electric force. Newton's second law is used to find the force of gravity. Electric field and force are used to find the charges of each tape, and Coulomb's law was also used. And the relationship between the electric force and distance of separation being inversely proportional, and then the charges being directly proportional to the electric force was also used. Here we can see that I've included the code I used in Python and also when I ran it what the image looks like. In the image, tape A is denoted by the blue sphere, tape B is denoted by the white sphere, the red arrow is the electric field created, and the cyan arrow is the gravitational force created by the interaction. In the experiment, we first started with trying to find the charge of the tape, whether that be negative or positive. And so to do that, we took the tape and used it and interacted it with different objects that had neutral charge. So we used a hand, a book, and a table, all having a neutral charge, and the tape 1 was slightly attracted to all of them based on the induced dipole from the tape's electric field. When we put the tape 1 next to tape 2, it was repelled. So we assumed that both tapes had the same charge, and when we put tape 1 next to a negatively charged pin, it attracted strongly, causing us to believe that the tapes were positively charged. The pin was given a negative charge after us running the pin through hair. The system we chose was that both tapes were in the system and the surroundings were all the other objects. Continuing, we knew that the length of the tape was 0.2 meters, we knew the mass of the tape was 0.0002 kilograms, and so with that, we found the magnitude of the gravitational force by multiplying the mass and the force of gravity. And finally, we knew that the force of gravity is equal to the electric force, so we used the electric force equation to find Q, which is the charges of both tapes, and that came out to be 1.868 times 10 to the negative 8 coulombs. Continuing with the experiment, we found that the number of electrons lost was going to equal the total charge divided by the charge of one electron. So the charge of one electron was 1.6 times 10 to the negative 19. And so we found that 1.17 times 10 to the 11th electrons were lost. To find the number of atoms, we took the area of the tape divided by the area of an atom, and we found that 4 times 10 to the 17 atoms were lost. For the ratio of electrons to atoms, we found that 2.93 times 10 to the negative 7 electrons were equal to, or were for one atom. Possible sources of error is that we handled the tapes too much, causing the positive charge of the tape to be affected. The distance we calculated between the tapes was off, or that the unequal charges on the tape really affected the experiment. So what if electrons had a positive charge and protons had a negative charge? What would happen? Nothing would change. Like charges would still repel each other and opposite charges would still attract. Our observations would remain the same. It is important. Why is it important to handle the charged tapes as little as possible? Because the neutrality of our hands would cause the tape's positive charge to try to neutralize again and affect the charge of the tape. Conclusions that we got were that Newton's laws can help solve for certain individual characteristics of objects, electric forces and fields are omnipresent, physical contact with objects affects the overall charge of objects, and that commonly used objects and their interactions can be observed as point charges.